Hey everyone, and welcome to this explainer. Have you ever actually stopped to wonder about the invisible plumbing that makes our modern digital experiences, well, work? Every single time you open an app or make a purchase or get one of those instant notifications, there's literally a massive, super complex conversation happening right behind the scenes. Today, we're going to demystify exactly how those conversations happen. We're looking at architectural strategies for inter-API communication. So by the end of this explainer, you're going to have a crystal clear understanding of the developer's communication toolkit. Let's dive in.
All right, here's our agenda for today. First up, how systems talk. Then we're going to tackle 4 completely distinct ways APIs communicate: REST, gRPC, webhooks, and PubSub. And finally, we'll wrap the whole shebang up with a unified strategy. Section 1, how software systems talk. The foundations of inter-API communication. So, let's frame the core problem here. Isolated software simply cannot scale alone, right? Inter-API communication is basically the architectural layer dictating exactly how disparate software systems talk to each other. In a modern tech stack, a single application absolutely doesn't hold all the answers. It relies on a massive web of external systems for, fetching data, updating state, handling complex transactions. This constant, totally invisible chatter, that's the very foundation we're exploring today. Section 2. REST, the everyday standard. Representational state transfer. Okay, so REST. This is absolutely the ubiquitous standard for getting systems to talk. It's the most common method developers use, utilizing standard HTTP to fetch information. Essentially, when a system needs data, it just sends a request over to a specific endpoint and, waits for a response. It's kind of the reliable, everyday synchronous backbone of most web traffic you interact with today.
And what's wild is how this method scales across vastly different necessities. On the everyday side of things, you've got your standard mobile app sending a REST request to pull down today's weather forecast. Pretty simple and straightforward, right? But it also handles absolutely mission-critical real-time scenarios. Think about a retail site that needs to instantly query a payment gateway to verify a transaction before confirming your big order. It's literally the exact same underlying method, scaling all the way from a casual weather query to absolute mission-critical operations.
Section 3, gRPC, high-speed internal chats, built for performance. Now, when systems require just blistering speed, developers turn to gRPC. Unlike REST, which uses standard HTTP, gRPC is actually powered by the much faster HTTP/2 protocol. Plus, it utilizes protocol buffers. What this does is compress the data, making it incredibly lightweight and super fast to transmit. Because of these specific traits, gRPC is the absolute go-to for internal communication, especially when you've got dozens of backend microservices that need to chat with each other simultaneously without bottlenecking the whole system. To put that into perspective, take a real-time use case like high-frequency trading platforms. In these environments, a millisecond delay can literally mean millions of dollars lost, right? Low latency isn't just nice to have, it's absolutely critical. gRPC strips away all that extra overhead to deliver data almost instantaneously, securing the crazy high performance needed for those high-stakes executions. Section 4, webhooks, the reverse API. Don't call us, we'll call you. So think of webhooks as reverse APIs. It's a push instead of a pull. Rather than a client constantly nagging and polling a server asking, hey, is there new data yet? How about now? The architecture is entirely event-driven. The client just sits back and relaxes. The server pushes data to the client only when a specific event actually occurs. You can really easily visualize this push mechanism through a workflow developers use literally every day. Let's say someone pushes new code to a GitHub repository. That's our triggering event. Because a webhook was configured beforehand, the GitHub server immediately pushes that event data out, and bam, an instant notification appears right in your Slack channel. Slack didn't have to sit there asking GitHub if new code was there. The webhook just delivered it automatically. It's a real game changer for efficiency. And we actually see this push architecture constantly in everyday consumer apps too. Like when your physical package gets scanned at a local sorting facility, the shipping company's server uses a webhook to push a real-time tracking update directly to your phone. It just waits for the physical event to happen in the real world and then immediately triggers that digital reaction. Section 5, PubSub. Simultaneous async messaging, message queues, and topics. Moving on to PubSub. This handles massive, simultaneous broadcasts through asynchronous messaging. Basically, services subscribe to specific topics. Imagine a radio broadcaster.
They send a signal out on a specific frequency, which is our topic. They don't know exactly who is listening out there, and they certainly don't wait around for a reply. They just broadcast. Meanwhile, multiple independent services act as the subscribers. They tune into that specific topic, listen for the broadcast, and then process the message entirely on their own time, asynchronously.
This setup is incredibly powerful for complex routing, like what you'd see on an e-commerce platform. When a customer places an order, the main system doesn't sequentially talk to the warehouse, and then the billing department, and then the email server. No way. Instead, it publishes a single order-placed message. Instantly, the warehouse service receives it and starts packing the box, the billing service receives it to charge the credit card, and the email service receives it to send out your receipt. One single broadcast yields simultaneous, asynchronous reactions across entirely different systems.
Section 6. Choosing your communication strategy. The Developer's Toolkit summarized. All right, so bringing this all together, choosing the right strategy really ultimately comes down to the specific software problem you're trying to solve. For standard synchronous data fetching, rely on REST, just like our mobile weather app. For blistering backend performance between microservices, implement gRPC, just like we saw with high-frequency trading. If you need to build systems that react to external events without that constant polling overhead, well, use the reverse push of webhooks, like those GitHub to Slack alerts. And finally, for routing single events to multiple independent systems all at the exact same time, leverage the asynchronous topics of PubSub, as we just saw in e-commerce order routing. Understanding these foundations really completely changes how you view digital architecture. So, here's a question for you to take away. Look at the technical specs you are currently building, or even just the apps you use every single day. Have you optimized your approach? Is that bottleneck you're dealing with actually a REST fetch that realistically should be a PubSub broadcast? Think about it. Thank you so much for joining me for this explainer.